Hi everyone. Now we are going to discuss on the various protective devices which is being used in the case of an electrical wiring. So here you can see that the power which is being received from the KICB or the electricity board, first it goes to the energy meter, then it is coming under the purview of the home premises where you need to provide the protective devices. So firstly here you can see that it is going to a double pole MCB miniature circuit breaker, then it is going to a residual current device RCD, and then it goes to the individual MCBs. So these MCBs you can just imagine it as a fuses, an alternative of the fuses which we were using it in earlier times. Now it is being replaced by MCB. So we will be discussing on these kind of devices which are being used in the case of a electrical wiring scheme. So this is again an actual drawing of the system. So here you can see that the mains power is coming to a double pole MCB, then to a residual current device, then to the power is being given to the individual miniature circuit breakers, and the power output is taken from the terminals from here, and the neutral is being taken from the neutral link. So which are the basic protective devices? So the first one is a miniature circuit breaker, which is being used for overcurrent or short circuit protection. The same feature goes to the MCCB, but it has a higher capability in terms of its rating. Then we are having the L3 Case circuit breaker. Is nothing but working on a voltage based system, and then you are having the residual current circuit breaker, which makes you work on the current which is passing through the phase and neutral. Then you are having residual current device and residual current circuit breaker with overload protection. So these are devices which we are going to see now. So a miniature circuit breaker is nothing but an alternative of a fuse, which we are using in earlier times. You would have seen that, or you can see at the energy meter point, you can see that a small fuse is there, so which is being installed by the electricity board. So when it comes to our inside purposes, nowadays we won't use that kind of fuses, and we will be using the miniature circuit breakers. So those are the electromechanical devices which has protection over the overcurrents which comes into picture because of the short circuit, overload, or a faulty design. And whenever there is an excessive current which is flowing through the miniature circuit breaker, the circuit breaker will be tripping by itself. So once it gets tripped, the thing is that you can again make the system to on condition by switching on the MCB. So you don't need to do an extra wiring or something in the case of a fuses which we were using in the earlier days. So basically there are two ratings are there. That is, one is a current rating, that is in the ampere, that is the maximum current with which it can work, and the short circuit rating is nothing but the amount of short circuit current which will flow through an MCB under a fault condition. And then depending upon the operating characteristics of the miniature circuit breakers, it is being divided into B or C or D type. And these miniature circuit breakers are available in the range of 0.5 ampere to 100 amperes. And so the MCB short circuit rating is nothing but the level of its ability to work under the case of a short circuit. And in the case of a domestic MCB, it will be working at a 6 kiloampere fault level. When it uses the industrial application, it may be in the 10 kiloampere fault capability. And all these MCBs are having a unique dimensions. That is, whatever be the manufacturer, the size of the MCBs will be the same. So in a box, we can put MCBs from different manufacturers. So the first characteristic is the overload, which is intended to be provided during the overloading of the cable in a no fault situation. So the MCB will be tripping depending upon the degree of the overload, and this is being achieved using a thermal device in an MCB. And the second point is the magnetic fault protection. So this will arise when the fault reaches a predetermined level and to trip the MCB within 1/10 of a second. And the third one is short circuit protection, that is, under the case of a short circuit, because of a fault, heavy current will be flowing, and that time you have to switch off the system in order to protect it. And the capability of the MCB to operate under these conditions gives it short circuit rating in kiloampere. So we already discussed a 6 kiloampere for a domestic purpose and 10 kiloampere for a industrial purpose may be required. So this is the inside feature of an MCB looking like. So you'll be having a supply terminal, then you'll be having a load terminal, and then you're having a bimetallic strap which is make a contact with the system. And this is nothing but the tripping mechanism. That is, this is a magnetic element. Here we can see a magnetic element. So when a fault or a high current is flowing through the system, this magnetic element will be reacting and that will be tripping the system, which makes the knob to the lower position. And because of the sudden tripping, there may be high temperature or sparks can occur, and in order to remove that, we are using an arc chute or an arc chute chamber, which is being shown over here. So the miniature circuit breakers, it can be classified according to the tripping over range, that is type B, type C, and type D. So it basically depends upon the amount of current at which it will trip. So a type B MCB will be tripped between 3 to 5 times the full load current, and they are basically used in the domestic applications. And type C MCB, the trip will be acting at a 5 to 10 times the full load current, and it is being used in the case of a commercial or industrial type applications. And type D MCBs, they will be tripping from 10 to 20 times the full load current, and it is being used in industrial applications where use of X-ray machines or large winding motors are being used. And now we will be seeing the different types of MCBs which are being used depending upon the number of poles. So the first one is a single pole MCB and the other one is a double pole MCB. Single pole MCB means it has only one pole which is seen outside. That means only the phase wire will be going to the MCB and the neutral is being wired separately without any circuit breaker. So it provides a switching basically in the case of a single phase circuit, and in the case of a double pole MCB you will be having both the phase and neutral will be entering to the MCB, and then from the output you will be again taking the phase and neutral. So in the event of any fault which is occurring in the system, the entire double two poles will be coming down, which will be isolating both the phase and the neutral. But in the case of a single pole MCB, only the phase will be isolated. Now we are having a triple pole MCB, which is being used in the case of a three-phase circuit. So you will be having the phases R, Y, B, which is being connected to L1, L2, L3, and then you are taking the output from the top side. So that is being used in the case of a three-phase circuit, and there is no neutral which is passing through the MCB. And the next one is a triple pole neutral, that is 3P plus N, triple pole neutral MCB, where you are having a one more terminal of neutral, but the thing is that the neutral is without any protection and it is something like an isolator. And whenever a fault is occurring, these three phases will be tripping off and the neutral is not automatically switched off. So it is an additional neutral is there, but it is connected to a separate pole. And the next one is a 4-pole MCB. That means all the three phases and the neutral are connected to a single pole. Okay, so whenever there is a tripping of the system, the entire system will be tripping down, and that is being used in the case of a unbalanced system whenever there is a change in the neutral current. So whenever there is an unbalance in the system, there will be neutral current will be there, and under such conditions, in order to protect the devices, we will be tripping RYB and then the neutral. The next one is a molded case circuit breaker. So the main difference is that they are having higher current ratings up to 2500 amperes, and the trip settings are adjustable. So it also has a protection against the overload. It also has a protection against the electrical fault, and it can also act as a switching circuit on or off. So the MCCBs are much more larger than the MCBs, and they are able to carry a larger amount of current. Okay, So they are being used mainly in the industrial applications and also used in the domestic applications. So they are available from a amperage of 15 amps to the industrial ratings of 2500 amps. So here this is a figure of an MCCB. Here you can see that your MCCB, it has a trip terminal is there, and then you can focus over here. So this is where the trip settings are adjustable, and that feature was not available in the case of a miniature circuit breaker. So in the case of a molded case circuit breaker, you are able to adjust the trip settings. So depending upon the amperage of the fault current, you can adjust the MCCB, so that it has an ability to do that. And you can also see it over here. One graph is there, which we'll be discussing on the next session. So adjustable trip setting calculus of MCCB. So IN is nothing but the nominal current. That is the nominal current which is flowing in the system. And 10 times IN is just indicating that 10 times the nominal current. So this is nothing but over the current you are having the x-axis and the time over the y-axis. So you can see that when the current is increasing on the x-axis, the amount of time which is required for tripping the system is lower and lower. So you can see over here it is going down and down. So for a 10 times nominal current, then it will be tripping at a shorter period of time, and for a 2 times nominal current, it will be tripping at a it will be taking more amount of time. So these kind of molded case circuit breakers, since it is carrying more amount of current, therefore it should have a withstandability to cope up with the pressure which is being built up in the system. So in the earlier case of a miniature circuit breaker, we have seen the arc chutes were there. So in the case of an MCCB, while it is tripping, the amount of temperature and the amount of gases which is being liberated during that particular period of time will be very high, and in order to protect the device, then it should have made of a higher strength. And this is nothing but a comparison of MCB and MCCB. So miniature circuit breaker and a molded case circuit breaker. And MCBs are available from 6 ampere to 100 amperes, and these are available from 10 ampere to 2500 amperes. Interrupt in rating is 18 kilo ampere is the fault current rating, and here it can go up to 200 kilo ampere. Trip mechanism, it can be thermal or magnetic. In the case of an MCCB, it can be thermal, magnetic, or electronic. Size, you have already seen the difference of the size. And MCCBs can be used in the outdoor, and the trip characteristics is being adjustable when compared to a MCB. And basically MCCBs are being utilized in the case of commercial industrial purposes and in the domestic purposes where a higher amount of power consumption is there. And the standard ratings of an MCCBs are denoted over here. And lower current ratings and higher current ratings are not readily available, but 6 amps, 10 amps are easily available, which we are using in our domestic purposes. And there is one more thing is that, which is an isolator. Isolator is nothing but a main switch. There is no protection. You can just switch on and switch off the supply. Okay, so it is acting as an isolation from the live terminals. So if you want to do a work over the system, what you can do is that you can just trip the isolator so that there is no live parts which is available at the end side. Then you have the distribution boards. Distribution board is where you are trying to fix all these devices. So it can be 4-way, 6-way, 10-way, 8-way, 12-way, like that.